In this lecture, we will talk about linear regression. But before we get started, I want to show you something cool, and that is how you also can add images to your notebook. So here you can see I'm using a markdown cell, and I'm using IMG, after that SRC, where I'm adding the source of the image, and then also the width and height, but this is completely optional. And I run the cell, and here I have an image, which can be especially useful when you're trying to present your data and explain your findings to someone. Okay, so now let's get back to linear regression. So what is linear regression? Well, first let's get started with a simple linear regression, and then we'll explain multiple linear regression. Simple linear regression is a statistical method that allows us to summarize and study relationships between two continuous variables. One variable, which is denoted x, is regarded as the predictor, explanatory, or independent variable, and the other variable, which is typically denoted y, is regarded as the response, outcome, or the dependent variable. And another name for it is also the predicted variable, which may help you get a better sense of what simple linear regression does. So let's look at the example that we will be working with. We will be working with a data set that contains prices from the houses that were sold. And also, it includes a lot of information, but one information that it includes is the square feet of living space. So in our example, we will have the price as the y as the dependent variable or as the predicted variable, and square feet of living will be x, our independent variable or the predictor. So we will be trying to predict the price of the house based on the square feet of living space. Now, regression analysis can result in either linear or non-linear graphs. A linear regression is where the relationships between the variables can be described with a straight line, just like we can see on the graph right here. But later on, we will take a look at logistic regression, which is different from linear, and you will see a non-linear graph. Now, the first step in finding a linear regression equation is to determine whether there is a relationship between the two variables, and this is often a judgment call for the researcher. Now, I have to give you a warning. Just because two variables are related, it does not mean that one causes the other. So let's take a look at some of the examples that we can use where we could use simple linear regression. So let's say we have SAT scores and we want to predict GPA scores. Now, of course, SAT could serve as a good predictor of GPA, but this does not mean that SAT scores cause, if you have high SAT scores, this does not mean that it will cause you to have high GPA scores. So these two variables may be related, as in a person who has lower SAT will also have lower GPA, but it does not mean that lower SAT causes low GPA. Now, some other typical examples of simple linear regression would be also if you have the IQ of the employee and you want to predict their performance with some numerical value, and also rainfall, and then as the predicted value of soil erosion. Later on, we will also talk about multiple linear regression, which is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. So, in the example that I was talking about that we will be working on, we may not only want to look at the size of the house in order to predict the price, but we may also want to consider the location and perhaps the last time that the house was renovated. So this would be all for the theoretical part, and let's try that all in practice.